Hey everyone. Alright, today's video is going to be over making predictions in probability. Your objective: I will be able to solve problems using quantitative and qualitative predictions. So last video we kind of talked about the fact that a prediction is a reasonable guess of an outcome, and we can use quantitative or qualitative data to represent it. Remember, quantitative has to do with numbers, qualitative is with letters. And probability can help us make predictions on a larger scale. So whenever you make a prediction, you want to use a proportion, and you saw me do that last video when I had rolled the die and I wanted to predict how many times I would roll a 3 out of, I believe it was 60 total tries. So whenever you set up a proportion, you want to create a label. So let's say the problem is trying to predict how many students would bring their lunch out of the total number of students. So let's say that for every 5 total students, 3 of them actually bring their lunch. And we want to know how many students would bring their lunch out of 800 students. Notice that whoever brought lunch, that's represented on top of each ratio, and the total number of students is represented on the bottom of each ratio. So then you would simply cross multiply. So 5x, that's where that comes from. And then 3 times 800, that would be 2,400. And then they isolated the variable, divided by 5 on both sides, to see that about 480 students would bring lunch. All right, so let's go ahead and do an example together. Example 1, a spinner is labeled A, B, C, D, and E. And we're assuming that all parts have an equal size. So it is equally likely for any of these letters to be landed on. So part A wants us to find the probability of spinning E. Well, there is 1 E out of 5 total letters. Now part B says if you spin the spinner 300 times, predict how many times it will land on E. So we're going to use words. We want to know the number of times it will land on E out of the total spins. So we're going to use what we found in the previous problem. So it would land on E 1 out of 5 times theoretically, but it wants to know what we can predict out of 300 total spins. So since that's the total, that needs to go on the bottom. So we're missing the actual amount it would land on E here. Now we can cross multiply. 5 times x equals 5x. And 1 times 300 equals 300. So 5x equals 300, and I need to isolate the variable. So I'm going to divide by 5 on each side. And x would equal 60. So we can predict that out of 300 spins, it would land on E about 60 times. All right, example 2. Suppose these buttons are in a bag and find the following probabilities. So let's say we have 440 total buttons. We want to predict how many would be red. So we are focusing on red. So we want to know the number of red out of the total number of buttons. So let's find how many red there are in the bag itself. So there are 1, 2, 3, 4 red buttons out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total buttons. 4 out of 10. That can be reduced to 2/5. So we could say that for every 5 buttons, 2 of them will be red. So we've got 2 out of 5. But now we want to know how many would be red out of a total of 440 buttons. So that's a total, so it goes on the bottom. And then we put x right here. Right, now we can cross multiply. So 2 times 440 would be 880. And 5 times x would be 5x. So 5x equals 880. Remember, we have to isolate the variable, so we will divide by 5 on both sides. Now I'm going to come over here to the left side of the screen and work that out. Alright, 5 would go into 8 once, with 3 left over. 5 would go into 38 7 times, with 3 left over. And 5 would go into 30 6 times. So if there were 440 buttons total, we could expect 176 of them to be read based on our prediction. All right, example 3. A restaurant says the probability of a customer ordering chicken is 1/4. A survey is conducted and 75 people said they prefer to order chicken. Predict how many total people were surveyed. So we are concerned about people who like chicken out of the total number of people. So the probability of someone ordering chicken is 1 out of 4. So one person would order chicken out of 4 total people. And then it says 75 people in the survey actually said they prefer to order chicken. So that would go on top of the ratio. And it says predict how many total people were surveyed. So in this situation, we're actually missing the total. Sorry, a poster just fell in my room, so if you heard something fall, that's what it was. Alright, so we're going to cross multiply. 1 times x is x. And then we're going to multiply 4 times 75. And that would be 300. So x equals 300. Now, the variable is already isolated, so we're actually done. X would equal 300. So 300 total people were surveyed. Okay, now it is time for you to try, so make sure that you show all of your work in your notes, and make sure you answer the problem on Educanon, and we will see you next class day.